Now we are glad to listen to Tetiana Obikhod. Are you here?
Yes, I'm here.
Perfect. So get ready to talk about the application of the dynamical system theory for counting black hole entropy of microstates. It seems a very interesting talk.
Yes, thank you. Yes, the title of my talk was announced. It is connected with dynamical systems and the possibility of calculation the entropy of such exotics as a black hole. Next, the plan of my talk is geometric nature of superstring theory, de Bruijn solitons, de Bruijn picture of the Hawking radiation emission process, various scattering processes, the string entropy, and conclusions. Geometric nature of superstring theory is very complex and unusual, but it has very great history. And it is connected with the superstring and de Bruijn theory. Superstring theory is one of the most advanced theories in physics that attempts to unify all the fundamental forces of nature into one single theory. It is based on the idea that all elementary particles and forces in nature can be explained as vibrations of ultra-microscopic strings. Mathematical models in superstring theory have their own unique properties and applications. They make it possible to describe various physical phenomena and processes such as gravity, electromagnetism, strong and weak nuclear interactions. One of the main properties of mathematical models in superstring theory is their geometric nature. They describe space-time as a multi-dimensional space in which strings can move. This allows us to explain many properties of space-time, such as curvature and topology. Next question is connected with de Bruijn as solitons. The use of mathematical models, about which I have said just a minute, in superstring theory also makes it possible to study the processes of birth and decay of elementary particles, as well as to explain the properties of black holes and other exotic objects. There is a formula for Schwarzschild matrix of such object as black hole. These models allow us to describe the properties of black holes, such as its radius, mass. Quantum gravity models are also used to explain the properties of black holes. For example, the loop quantum gravity model allows us to describe the properties of black holes as microscopic level maybe. De Bruijn picture of Hawking radiation emission processes. In this slide, I presented two de Bruijns and strings between them. What would I have done it? In most physical systems, the thermodynamic entropy has a statistical interpretation in terms of counting microscopic configurations with the same microscopic properties. And in most cases, this counting requires an understanding of the quantum degrees of freedom of the system. For black holes, this has been a long-standing puzzle. What are the degrees of freedom for black hole? Recently, there has been remarkable progress in understanding some string solutions, solitons called de Bruijns. De Bruijns, there are the black surfaces, and strings are ended on the same d brane or can connect different d branes. This fact presented in the slide lower. Bottom. Various scattering processes. Hawking radiation is described by open strings colliding and forming a closed string that leaves the soliton. We know that Hawking is a known great scientist who studied the properties of black holes, and he predicted the radiation of black holes. So this radiation is called Hawking radiation. But what about strings and the treatment of the entropy of black hole in terms of string? So in the right hand of this slide, I presented configuration of intercepting d branes. Open strings go between different branes. It's necessary to consider in right approach black hole, usual black hole of physical picture. Doing an average over the initial state of black hole, we get thermal Hawking radiation with the correct value for the temperature and the radiation rate. And it is proportional to the area of the black hole. It is a known formula of Bekenstein-Hawking. In the right hand of this slide, I presented the d-brane picture of the Hawking radiation emission process. We can see that two strings can collide and then they form closed string that leave this d-brane, and it is connected with Hawking radiation. The string entropy. The entropy of a black hole from string theory was calculated by Susskind, known American scientist, theoretic. The calculations of the string entropy is realized through the consideration of a multidimensional lattice of points with the strings inside it, which can move in any of 2D directions. We know that d-brane theory is connected with multidimensional space. As usually, it is considered 10-dimensional space. For our usual 3 space and 1 time, and 6 another dimensions, extra dimensions. They may be considered as a Calabi-Yau space or Arbifold or some other spaces, and so we can move in these d directions. And accordingly, entropy can be calculated as through the consideration of black hole as cube with strings inside its cube, which can move in 2D directions. 2D because d-brane is surface. Next, the string entropy is connected with the consideration of mathematical models in the aspect of the theory of dynamical system. Through the concept of topological entropy to describe chaotic behavior in dynamics. I must say that dynamical systems are a very useful apparatus for consideration, for calculation of different physical tasks. So this talk also connected with the application of this apparatus to consider the formulas of different topological invariants which can characterize such exotic object as black hole. One can calculate the volume entropy of such space through the following formula. HV is proportional to logarithm of volume this space. As we consider such n-dimensional cube, the volume of this space is equal to 2D and to n power. The volume entropy is always bounded above the topological entropy of the geodesic flow on M. Moreover, if M manifold, which is connected with vector bundle, which is described by black holes, moreover, if M has non-positive second curvature, then topological entropy is equal to volume entropy. From the other hand, we know that topological entropy is larger or equal to logarithm of the degeneracy of F, степень, украинским языком, ступень. Next, we know that if we consider the isomorphism of 2D dimensional spheres, which are associated with our black holes, then we can determine the degree of mapping, which is equal to 2D. It is known fact. We can find it in different books. For example, I found it in book of Katok. Therefore, the topological entropy of the system of n links of strings with length L, which is equal to Ls to n. Ls is characteristic length of string, n is the number of the string. Then the topological entropy is equal to n producted to logarithm 2d. The Lefschetz number of the link is equal to the degeneracy of F by the following formula that is presented on this slide. And therefore, it is equal, according to our calculation, to 1 plus 2d to n power. So according to the Lefschetz formula, we can calculate the index of the isolated point on manifold M. Considering the Poincare theorem, index is connected with Euler characteristics, and therefore Euler characteristics is defined by the formula presented in the bottom of this slide. 1 plus 2d to power n and at once to power n. What can I say as conclusion? We presented an interpretation of a black hole in terms of a collection of de Bruijns of different types, the Hawking radiation of which is carried out due to the radiation of closed strings. This interpretation of black holes allows us to imagine quantum degrees of freedom in terms of putting many open strings on the de Bruijn. The calculations of the string entropy is realized through the consideration of a multidimensional lattice of points with the strings inside it, which can move in any of 2D directions. Within the framework of the theory of dynamical system, we carried out calculations of topological entropy in accordance with the fixed point theorem. Considering the Hopf-Poincare theorem, we calculated the Lefschetz number and Euler characteristic of black hole, represented as multidimensional cubic space. These characteristics are interpreted in terms of elementary particles. It is known fact with which connected too many works of Witten, Waffa, Green, Schwarz, and so on and so on. Thank you for the attention.
Thank you very much. Very interesting.